Alright, so now we're going to look at ANOVA, which is looking at to test the difference between group means. So we can see here that we have two predictor variables that are divided. They're each divided into two kind of groups. They consist of two groups within them, totaling four in all. And here, if we were interested, we are able to look at some of the descriptive information to learn a little bit about more about the composition of our groups. Here we've got Levene's test of equality of error variances, which is really looking at this assumption of homoscedasticity that is just a part of ANOVA. And it's testing the null hypothesis that the error variance of the dependent variable is equal across groups, which would go against this idea of homoscedasticity, this assumption. And we see that because it is not significant, this value is above the 0.05 threshold, we can actually reject the null hypothesis and thus kind of meet this assumption of homoscedasticity of ANOVA, which is good. So now we come down here to what is basically, in my mind, kind of the money table, where a lot of our really rich information is about our data. We can see that in our corrective model, it is definitely is quite significant, which is good, very good to see. It's important then to come down though to R squared and see really how much variance our model accounts for. We can see that our model accounts for 0.495, which is again quite good. This also, in doing this, we kind of draw attention to Rogers and Neiswater's article about R squared being kind of a good way to look at how ANOVA predicts the strength of an effect in addition to the significance test. R squared kind of strengthens our assumptions, which is good. So moving on, we see that we have a significant main effect here of our first variable, of our predictor variable x1. We do not have a significant effect here of x2, but we do have a significant interaction here, which again makes me kind of, it reminds me of the antabuse example in class, where x1 perhaps could represent the alcohol in that context, where it would have, we have an outcome variable, perhaps illness, we'll say, or altered state, where it does have a significant effect. X2 does not have a significant effect. We can say that that would be antabuse, which on its own does not. And then, however, when they're combined, we do indeed have a very significant effect as well. And then looking here at the partial at a square, this is another good way to look at kind of the magnitude of the effect, which again gets at the magnitude being larger here in this interaction. Again, kind of going back to the antabuse example. So here we can see some of the kind of details of the differences between the means of the groups within each of our predictors. Here we can see that there is a difference, but we do not know if it's significant. We see exactly how much that difference is right here, and that it is in fact significant, which is in line with what we saw earlier in the previous chart. And in here, again, we see that there's a difference in our second variable, our second predictor variable between the two groups, but we see in fact that this is not significant. And then moving down further, which is again in line with what we know, moving down further, this chart will give us a good kind of idea of the details of the effect, where exactly this interaction effect, what exactly is occurring. And this is more relevant when we get more and more groups involved, and there's more and more going on, because then we can really tease apart exactly what's happening. As we only have two groups, in each kind of variable, each predictor, it's perhaps a little less relevant. So here now, actually what I'd like to point out, just go back up here and just draw attention to the fact that all of these F's are positive, and this gets at one of the articles, the Lay article, that talks about the F curve being only one tail, and in the sense they're all positive, and thus testing at a 0.05 level of significance is perhaps too stringent and might leave us open to type 2 errors. So missing an effect when it is there. And then the last little part here is just to look at the chart, and we can see visual representation that this is an interaction effect. If they were parallel, these lines, that would not be good. That would not indicate an interaction. And just to close, Another use for ANOVA discussed in one of the articles is this idea to look at rule-based models. So you're looking at the significance of testing the significance of rules through ANOVA by using the rules kind of as predictors to determine how much variance each rule accounts for. So just another use. I think that's it, and thank you very much.